Thanks for joining our session. It's always nice to be the opening act here. I have a great day of sessions. Like she mentioned, my name's Ben Snively. I'm a specialist SA in data and analytics and AI ML. What we're going to be talking about in this session is really how can you use analytics, big data, and merge that with AI technologies, machine learning technologies to both be able to drive insights for your organizations as well as add intelligence to your solutions. And we'll do that by going through a couple of different flows. Essentially, what we're going to do first is talk about analytics and some common pitfalls we see our customers have. That way, you don't have to find yourself in that same situation. We're going to give some demonstrations throughout because it's always nice to show real running systems as you guys are seeing this, and then some final tenets. Big data analytics are defined many different ways by different customers. What it really boils down to is either high velocity data, high volumes of data. You don't necessarily have to have petabytes and terabytes of information to have big data problems. Sometimes it's unstructured data. Sometimes the data is coming at you very quickly. You need to be able to capture it, store it, analyze it. So big data oftentimes is categorized in different types of Vs. And we won't necessarily spend a lot of time defining 3 Vs, 5 Vs, 7 Vs, that sort of thing. But if you take a look at industry and what analysts are saying, it's very consistent with this. So over 90% of today's data was generated in the last 2 years. The rate of data generation is constantly growing. A lot of it is unstructured data. And a lot of it is coming very quickly from IoT sensors, from clickstream data, various data sources. But what really matters isn't necessarily how you define big data, where the data is coming from, but really being able to drive insights from it. So how can you use this data to be able to really drive insights and power your business? And what that really requires is new ways of analyzing your data. So a lot of times, in traditional approaches with relational databases, with data warehouses, those approaches work very well for structured data that you fit your data into that particular structure ahead of time, and then you run reports, you run analytics on top of that data. But as your different data sets are changing, as you're collecting unstructured and semi-structured data, maybe it's imagery, maybe it's video. We're going to show some demonstrations of that later in the session. Being able to run new types of analytics on that data is really key. And that's why we're really seeing this hybrid architecture, or this architecture that is really complementing those databases and data warehouses with the concepts of things like a data lake. How can you have really both of those benefits where you have that high performance data warehouse, but you're also able to do big data analytics, Spark, Impala, Presto, these sorts of analytics on your data. You might also want to be able to do image recognitions, audio to text transcriptions, those sorts of things on different sorts of data artifacts to be able to power that solution. The other really key thing is being able to plug in those machine learning algorithms into your framework. And a little difference, comparison between a database, a data warehouse, and a data lake, where with databases, it's schema on write. What that means is, I define my schema up front, and if I want to load new data in that schema, I use an ETL tool. It might be our tools. It might be some of our great partners like Informatica, Talend, CloudBeam, Attunity, all these partners that provide really good ETL software. But you're really taking that data and fitting it into a schema that you defined. Data lakes are a little different, and that's why they complement each other really well. With data lakes, you're able to store all your data up front. So when we're given our first demo, we're actually going to be demoing where we have data already stored in our data lake. And we want to start understanding that data and analyzing that data. It might be at first just understanding what the fields are, what the distributions of the fields are, how are those fields correlated. But it might also be advanced analytics and machine learning on that data. Maybe I want to predict something like customer churn or citizen, how happy our citizens are. Or maybe I want to recognize things in these audios and these videos and those sorts of things. So those things, data lakes and data warehouses really work very nicely together in those solutions. The The other thing is, with data lakes on AWS, essentially how we're seeing those architectures evolve is really having essential storage on AWS. And S3 is the core piece of a data lake on AWS. So S3 becomes that central content storage. It provides 11 nines of durability. What that means in kind of layman terms is if you store 10 million objects out on S3, you may on average lose one in every 10,000 years. So that's kind of, if you think about that, data durability is very, very fantastic on S3. In a past life, I built Hadoop clusters on premises. And if we tried to achieve 11 nines of durability, that was nearly impossible because we're always in one data center, that sort of thing. So amazing, amazing data durability. So with that data lake and that data durability on S3, there's some other aspects to that data lake. So on the bottom here, you'll notice the storage piece. You also need very, very rich life cycles of your storage. So your most recent data, oftentimes you're accessing most frequent. So how can you make that very, very hot, easily consumable by your analytics? But then also being able to categorize that data. It's interesting because metadata management is a very common aspect that's overlooked by folks that are standing up data lakes, analytics, machine learning on AWS, and really anywhere. So being able to categorize your data so you could find it and use it within these tools is really, really key. So that's really the foundational part. But then you also have how you get data from on-premises into the cloud. How can you get data from software vendors or software as a service vendors into your system? How can you capture real-time data, clickstream data, IoT sensors, connected sensors in cities, smart cities, that sort of thing? So these are all aspects of the data lake kind of centered around that S3 storage, that raw storage of being able to have those bits in S3. There's a lot of other facets, so very, very important aspects like data security, auditing, logging of all the access of your data. We could easily spend an hour on any of these boxes. But what we're going to do in this session is we're really going to focus on the analytics and machine learning of your data and also the metadata management of that data. So I want just to include this slide to say there are these other parts worth considering when you're looking at your solution. And the AWS services work very, very well together and with our partners to be able to provide aspects of these components. So here's some of the services that fit into these different categories of being able to collect and ingest your data, categorize it, analyze it. And again, we're going to spend a lot of time on the analyzing, metadata management, and machine learning of the data. So before we jump to some demonstrations and how to really do this in practice, what I like to include a lot of times are what are some of the most common issues, common problems, things to consider when you're looking at building an analytical system, machine learning system, both in general and as well as on AWS. The first analogy that we like to give a lot of times is what tools should I use? If you look at the ecosystem is very, very giant. So you have a lot of options to you in terms of what tool to use for different jobs. And what we like to say is, pick the best tool for the job you're trying to do. So rather than trying to use a giant Swiss Army knife that, sure, it has a screwdriver that you could screw in a screw, use a drill to screw in, the screws that you need to screw in. If you need to, build a shed, build a building, you want to use the right tools for the different purposes of that job as you're building that. And the same sort of thing really applies when you're working on analytics and machine learning. Pick the right tool for the right type of job. So if you're doing an image classification, certain tools are really good at that. If you're doing audio to text, certain tools are really good at that. If you're doing forecasting and time series analysis, other tools might be good at that. So rather than picking one tool to be able to do every one of those sorts of analytics, really pick a framework that you're able to plug in different analytics into a common platform and run those for the right type of problems. So with AWS, and you guys are probably aware of this for the folks that have used AWS, really all of our services are purpose-built. What that means is each of the services does a function very, very well. So we have services that are able to capture real-time data and process it very, very effectively. We have services to be able to capture CDC logs from databases and populate your data lake. So these are very, very purpose-built services that do that function very, very well. So that's great, but if you look out in the forecast of all the data analytics services and all these purpose-built services, this is what you might see. So there's a lot of different options out there for you to use. And really what's most important as you're building these analytical systems on AWS in general is not necessarily go into analysis paralysis of what's the perfect tool that I should use for every single use case, but put together a framework that you could experiment. So experimentation and agility is really key. Try out a couple different tools to see what works, and iterate on that, adopt the solution. And we're going to talk about a couple case studies of customers doing exactly that. So rather than trying to spend 6 months trying to pick a trace study of what's the perfect tool, being able to try out a couple different tools in a bake-off, pick the right one, and then essentially keep iterating on that. So this is a really good quote that I like to kind of steal or reuse from Gartner, where very, very recent, they're saying in this year, in 2018, 80% of the data lake efforts are actually going to be ineffective because of poor metadata management. I work with a lot of different customers that are new in this space, and they're storing data out there, but as soon as they start trying to analyze it, it's a real challenge trying to find where is the data located, how do I access it, that sort of thing. So metadata management is really a key piece of a lot of these analytical systems. There's a couple different ways of doing this. One of them is using a service called AWS Glue. We're going to demo this in a minute. And the reason that I like to talk about this as an option is one really, really key feature, that bottom one that's listed there. One is it's able to crawl your data repositories and discover your data. So with metadata management, creating that metadata catalog is really important up front, but maintaining it over time, because your data sets change, your schemas change, and being able to have a consistent model of your data over time is really, really important. And the crawlers are able to do that. They could be scheduled so that it updates your schemas over time. And the other really important aspect, so if you're using Glue, if you use one of our partners, that's great as well. But one of the really important aspects is making sure the metadata service that you're using is very, very supportive of different analytics that you could run. You don't want to necessarily pick a storage platform and a metadata platform that now you're pigeonholed into using one sort of analytic. You want to be very, very have kind of analytics freedom to be able to run deep learning, machine learning, real-time analytics, Spark, those sorts of things on your platform very, very effectively. So there's other ways of populating your data set besides just crawling it. It's really, really powerful to get started using that. But you can shift your metadata catalog across different toolings, different vendors, that sort of thing. One of the options is actually to go from a Hive metadata store in a Hadoop cluster into a common data catalog in Glue, and vice versa. You could go in and out of that. So how can I get started? How do I kind of essentially start kicking the tires with this? One of the examples I like to give, this is the only commercial example I'll give. The rest are public sector examples. But Netflix got started very early on AWS. And the reason I like to show this is it really shows how you could innovate and change your platform over time. So really, one of the most important things, like I mentioned, is picking a platform where you could change how you're doing things. So they actually started with an open source project to be able to do their data ingestion platform. They're using this Apache project. Unfortunately, they started using it, and about shortly after that, it stopped being maintained. It went about 2 years without being contributed to. So they wanted to shift. So they shift to a project called Apache Kafka. It's an Apache project for real-time processing. So they're able to shift to that pretty easily and use the Kafka routers from their producers. But then they wanted to be able to start shifting out that project, that open source project that isn't being maintained anymore. So then they went purely Kafka to be able to do all their real-time data. And the reason I like to mention this is what enabled them to do this is putting their data in S3, being able to have their producers use open standards. So it's very easy to talk to Kafka. It's very easy to talk to this other open source project. But it's also very easy to talk to our managed services like Kinesis, which they moved to after that. And the reason why they did that is running Kafka is great. Kafka is a really great open source project. But when you're doing that, you're doing things like managing Zookeeper, which is a coordination service. You're making it HA, highly available across AZ. So there's a lot of other heavy lifting that you need to be able to do when you're running that real-time analytics. And by shifting to higher level services like Kinesis and some of the other ones we're going to dive into in a moment, it really lets you as customers and organizations focus on the analytics, the driving insights, that sort of thing. And really, being able to do that rapid shift, that let's test out this framework, fork some of our workload, see how it works, and then shift over to that is really key to be able to do that. So, really that agility, being able to experiment and be agile with the analytics you're running. It's interesting because on Amazon's Prime Day, Amazon Retail uses many of the services. They're a customer of ours, just like many of other customers. But during Prime Day, the NoSQL database DynamoDB actually peaked at about 12 million requests per second. And they're using that NoSQL database. They're using it as both a key value store and a document store. And the retail side of the business just needs to focus on how do I structure my objects, how do I get them out, and the AWS services will structure the right way, auto scale, consume those messages, consume those requests, and scale back down. So really, really powerful to be able to have that agility, that scale, that elasticity as you're writing your analytics. So speaking of analytics, I could definitely spend multiple days talking about analytics, so don't worry, I won't. Many types of different analytics out there. So the first I like to talk about is a Hadoop and Spark analytics. Curious folks in the room, and I should have asked more up front, how many folks in the room are doing some sort of Hadoop or Spark today for their organizations? OK, a couple hands, maybe like 4 or 5 hands came up. So Hadoop and Spark is a platform to do massively parallel processing, different sorts of analytics, both on premises and in the cloud. It started with very patch-oriented, but then additional libraries and frameworks went on top of the ecosystem to be able to run different sorts of analytics. And what makes us really powerful in the cloud is, excuse me, is being able to really focus on writing those analytics and using EMR, for example, Elastic MapReduce, to be able to spin up these clusters of elasticity. You could run multiple clusters in parallel. For example, if I want to spin up a real-time cluster to do analysis of streaming data, I could do that very effectively, pay per second, shut it down when I'm not using it. And then if I have some ETL jobs, I can spin that up. So it really becomes a resource that is very elastic, just like compute and that sort of thing, but in the analytical space. And really what enables you to be able to do this is that data lake or that common storage on S3 and that common metadata catalog that's describing that data. So very, very common to have real-time clusters that are running 24/7 and automatically scaling based on the workload, and then these other transient clusters all pointing to that S3. And for the folks that are running Hadoop, essentially the way that works under the covers is S3 is presented as if it's HDFS to that cluster, and then that cluster also has working space on the cluster itself for intermediate files to be able to be very performant when spilling to disk, that sort of thing. And the way this works, of course, the data is described on S3 or essentially stored on S3, and then one of these metadata management stores, for example, the Glue data catalog, which we're going to demo here in a couple slides. You can actually run your own metadata catalog on managed relational databases we provide. Folks like FINRA got started very early on a data lake, and we're going to talk a little bit more about FINRA in a moment. But they actually created their own metadata management called Herd because Glue wasn't out yet. And Herd is an open source project that you could very easily run as well. So customers, it's all about choice. Our services work very, very well. But you have choices in terms of using some of these different projects when it comes to these different architectural approaches. So last thing I want to mention real quick, and then shifting to the first demo, is Athena. So Athena is one of our newer services in the analytical space. And what it really allows you to do is issue select statements against your data lake. And remember, the data is actually stored in the raw form in this case. So the data is stored as CSV, JSON, Parquet, Avro, these XML, these different formats on S3, and I'm issuing select statements as if it's in a database. It's not really loaded in the database. It's actually a schema on read, so it's actually inferring a schema as it's executing, which makes it very, very rapid to be able to test things out. So if you're bringing in a completely new data set from a vendor, from a partner, you want to start experimenting with data fusion, very, very easy to be able to query the data in place before you load it into your databases, your data warehouses, that sort of thing. So we're going to go ahead and shift to a demonstration here. And we're going to really start with the data catalog. And within the data catalog, what we see here is this is the Glue console. And essentially, we actually see these different tables here. And I should say tables in air quotes here, because some of these are like traditional tables, like in Postgres and Redshift that you see there. Redshift is our petabyte scale data warehouse. Postgres is an open source database. But these are also the schema on read data lake tables. And so you'll notice also things like CSV tables and Parquet tables here. And these are data sets living on S3. So you'll notice the location there says a S3 path that we're going to be able to analyze and start querying the data in place. Very, very powerful to be able to do that as you're investigating your data. But before we do that, I'm actually going to demonstrate that crawling feature. So this is a crawler configuration. Each crawler runs within an IAM role. So all of these services are integrated very, very nicely with our security layer, IAM, which is Identity and Access Management. So it allows you to do least privilege access for all of these components, so that when you set up your crawler, it's only, even if it's misconfigured, it's only going to crawl the buckets that your security posture allows it to crawl. So that goes without saying with all of the services we're going to go through, that it's really a key part of integrated throughout all of the tiers we're going to look at. So we're going to run this crawler. And this isn't recorded. This isn't staged. This is kind of given a live demo. I happen to be hitting US East, so it's not hitting Dublin or one of the more local regions. But we're actually crawling this data set here. And what's really cool is within a couple seconds, what's going to happen is I'm going to be able to refresh this, and all of a sudden, the list of metadata fields in my catalog just went from 3 to 13 within this data lake schema. So what we just did is, you could look at the timestamp. The timestamp is actually right now. And we actually just discovered all of this data just now. And what's really cool is, even though we just discovered all this data, we can start querying it in place. So this is the S3 location that Twitter data is actually getting fed into my S3 bucket. S3 happens to be, or Twitter happens to be in JSON, so we can see that. We can also see things like all the fields, and you'll notice JSON, CSV, all of these data formats actually don't have types, right? All of it's ASCII, all of it's string, but it's deriving the type for me. So, so it's deriving, these are Booleans, these are integers, these are strings. I could very easily go in here and modify that. So let's say I'm looking at flight information, and flight number, if you just look at the data type, might be a numeric value. But I might want to treat that as a string because there's no significant value of taking like an average flight number for a carrier and doing numeric functions over that. So I might want to change that to be a string rather than a flight, integer, that sort of thing. So you could go in and change your schema on the fly here. The other thing that it allows you to do is for very nested objects like tweets and a lot of other data formats that have JSON that's very nested, where it has fields within fields and arrays within fields very, very deep in there. What it automatically just discovered live here is the crawler actually automatically discovered this array of structs, which actually goes quite deep. I would not want to try to create this DDL, this create table statement, that has all these different fields in here. So really, really powerful to be able to have it scan all your data, secured through the IAM role, so it's only going to scan the data you allow it to, and derive all of this information. I'm going to save some time for some of the really cool demos in the machine learning here, don't worry. But one of the other things that I wanted to show super quick is how you can start looking into this data. Athena is that SQL interface into your data lake. So we're going to actually look at this data set, this taxi data set. This is a CSV data set that we just discovered just now. And what we're going to do is we're actually going to go in here and say, I want to look at this data. I want to view this data. And even though this is CSV data, and folks in the room, feel free to kind of give me thumbs up, thumbs down. I can zoom in and zoom out. I can almost see people in the back. Or go like this if you can't see. I'll try to make it a little bit bigger. But what we're showing on the screen is essentially just a select star limit 10. And what that's doing is it's actually scanning through that CSV, returning me back the first 10 records. What's really powerful is you could actually create your own, let's say you have a very custom format. Let's say it's some very unique log format that you could describe through regex. What you could do is you could actually describe that in your data catalog once, and then within Athena, within Spark, within Hadoop, within all these environments, that's abstracted away from the people using that data. So you define it once in your data catalog, and then the people running your analytics don't need to know special ways of parsing these different log files. It's done through the adapters or through the SERDES within the catalog. The other thing I'll show here very quickly, and I always end up mistyping queries, so I'm actually going to just paste this one in, is this is actually a little bit more complicated of a query. And the reason I want to show this is, this just took 2 seconds to query. So remember, this isn't data in a database. This is data like at rest on S3. I'm paying very, very minimum cost when it's kind of sitting there. And I actually just did a count query, a maximum fare. This is the New York City taxi data. It's 10 million entries in this one data set. Sometimes when we have a longer demo, we actually query 8 years of this data, which is about 3 billion entries, which is really cool when it returns in a couple of seconds and you're querying all the data. But in this shorter session where we're talking about multiple things, we're going to just use this data set. But we're able to do averages, maxes, fares, things like correlations. So we're calculating the correlation between the fare amount and the distance, the fare amount and the total amount. So a lot of these correlation queries are things that you do a lot of times in the data science side as well as you're starting to understand your data. So this is really letting you take massive data sets, query over the entire data set, and be able to calculate correlation matrices, that sort of thing, overdoing. You can't do sampling, that sort of thing. So Athena is one way of querying the data. Another way of doing it is essentially being able to use Spark and Presto, essentially the ecosystem on the Hadoop clusters. So I actually spun up this Hadoop cluster, a little bit before the session. It hasn't been running very long. It's actually been running for 2 hours now. I just spun it up to be able to give some demos. But the really cool thing here is this entire cluster, this analytical ecosystem, I can spin up with a click of a button or through programmatic scripts, and then it plugs into that data lake and that data repository metadata catalog on S3. And what I could do here is I could spin up things like Zeppelin notebooks and start doing all types of things like Spark queries, analytics, visualizations. Sorry, you guys probably can't see it in the back. I'll make it a little bit bigger. But you'll notice when I say show tables here, this is the entire table list that you just saw that we discovered through crawlers and that sort of thing. So when we we run this, that sort of thing, we're actually pulling the most recent crawlers that crawl data, that sort of queries against the data lake. You're also able to do Spark ML in here. So you're able to connect into the data within the data lake through the catalog and do recommendation engines, alternating least squares, all types of different analytics within this notebook. The entire ecosystem has a lot of different UIs that you're able to do on top of it. And it's all about being able to enable different users to use these different tools because they're oftentimes doing different jobs. So next, what we're going to do is we're actually going to shift back to the presentation, give a quick introduction of machine learning and how this is really powering a lot of machine learning. And then we save some really cool demos for the second part here. So, why are we bundling this talk with big data analytics and machine learning together? And really, data is a key enabler for machine learning. So without data, data is really a key ingredient. So you need the frameworks, and you need the infrastructure, and you really need the data to be able to do machine learning. And what we're finding is it's really a flywheel effect. So as our organizations, as customers are generating this data, storing on S3, being able to analyze it to make better decisions, that's really driving better services for their citizens. It's better education tools, better products that they're providing. And this is all driving more users, more data, and this becomes a flywheel effect that really is powering both big data systems as well as machine learning systems. So on the data lake side, what we're seeing is the analytics piece and the machine learning piece all working together with that data lake. And with machine learning and analytics, what's really key is not necessarily picking one interface. Just like you wouldn't pick one analytic to solve every problem, you don't want to necessarily pick one interface for every single user. You, of course, want security throughout your layers. You want to be able to have auditing, all those. But you don't want to necessarily say everyone's going to use a BI tool for every purpose. BI tools are great, but oftentimes you want to use notebooks, and you want to use other environments for your data scientists, that sort of thing. So different tools are used by different folks within your organization to be able to do your analytics. And we have a full machine learning session towards the end of the day here today. So we're not necessarily going to step through all of the different services within these tiers when it comes to the application services, platform services, and framework services. But what I did want to mention here is when it comes to your data in your data lake in S3, it's very, very easy to use different levels of services based on your skill sets. So we have customers that are bringing different data sets into S3 and doing things like creating content repositories that is easily searchable without having data science skills. And the way they're doing that is being able to use these application-level services. So these services are really built with machine learning and deep learning under the covers, but it's very easy to plug in your data, get results out to be able to do language services, machine translation, image and video recognition, that sort of thing. Then we have platform services. So these are services like SageMaker and Deep Lens and EMR that lets you really plug in your own data to build very custom models and then deploy those out to either endpoints hosted in AWS or endpoints out on the edge. It could be a connected car or drone, whatever it might be. And then lastly, we have frameworks, very, very powerful for the data scientists, to be able to spin up very, very powerful infrastructure, either on GPUs or Intel CPUs, and be able to run those very, very effectively on AWS. One example I like to give here is Digital Globe. So Digital Globe is a customer of ours. They built a data lake on AWS. It's about 100 petabytes. Anytime you're using mapping software, a lot of things leverage Digital Globe data because they take imagery across the globe and run analytics on that. And this is an interesting use case because, of course, they're doing geospatial recognition for like oil and gas companies and image processing on the images themselves. But they also wanted to be able to drive down their costs using machine learning. So what they did is they actually have multiple tiers of services. And they're able to use SageMaker to actually improve their cache hit by over 2 times what they were having before. So now they're averaging around 83% cache hits, sometimes about 90%. And what they're able to do by doing that is actually drive their costs down. They're paying about half of what they did for storage by leveraging machine learning algorithms to be able to predict what data people are going to request before they request it. And this is just a video here showing some of the cache hits. It's nice animation. There's a couple presentations on this from re:Events on our YouTube channel if you want to learn more about this. And this is what their architecture looks like, being able to step through there. One last example, and then we're going to dive into the essentially the machine learning demo, is FINRA. FINRA is a very large financial regulatory organization that really monitors stock trade inside the US. They're actually monitoring tens of thousands of security firms trying to do things like predict market manipulation. They built a 20 petabyte data lake, and the reason I like to talk about them as an example is they're really doing a mix of analytics as well as machine learning together. And the way they did that is they first looked at building a data lake and enabling analytics. So they're running multiple Hadoop clusters for different jobs. They have a very large NoSQL database running HBase, and all powered by S3 on the back end. But what's interesting is as they were evolving this architecture, they actually started here and then wanted to enable their data scientists using these different tools. So they're leveraging different tools to do these different jobs. And then lastly, they want to be able to run different sorts of analytics. They want to be able to run R, not only R, which they're running very heavily on premises, but they want to run TensorFlow and MXNet and Caffe and all of these other machine learning and deep learning technologies. So it was very easy for them to plug their data science platform into their data lake and run it within AWS using a suite of tools, not just one tool. So from here, we want to give some demonstrations of machine learning. So I wanted to welcome Kate to the stage, and she's going to run through some of those.
All right. Okay. All right, so good morning. My name is Kate Werling. I'm a solutions architect. So I have two demos I want to show today. I work specifically with the public sector, so both of these use cases are actually public sector use cases. So hopefully a lot of people here will find them relevant. The first one today is termed a reverse image search. So we had a customer that came to us and said, you know, we have all these security cameras throughout the city, and we're collecting all this data all the time, but we're having a really hard time being able to go back and query that in a meaningful way. So what we want to show is how they could leverage a service like Rekognition to help tag their data and their images as they come into the system automatically. So what we had was we actually had two of our solution architects on the team. They put a dash camera on their car and then drove all over the city in DC and took pictures of traffic as they were driving along. They then took these images and uploaded them into S3 and then passed them through Rekognition and built out a DynamoDB database that contains all of the object tags as well as the geolocation metadata. And then we were able to build this nice little user interface so you could go ahead and query the data based on the tags returned by Rekognition. So if I search for something like a car, I'll get back a collection of geolocations associated with that vehicle. And unfortunately, it's taking a little bit of time because this is hosted in the East region. There it goes, of course. OK. So, you know, of course, there are a lot of cars, unsurprisingly. So as they're driving around, a lot of cars were identified automatically using Rekognition. So I'm going to search for something a little bit more specific. Let's look for a school bus. And let's say I want to only see images that contain a school bus with greater than, we'll say, 80% confidence. I'll go ahead and search. OK, so there's only one. All right, so here are the geolocation coordinates of that school bus. When I click, it will take me over to where the school bus is. This is actually where on the highway they saw the school bus. We can see the different tags that Rekognition generated from the image. And then whenever we click, we can see the original image. And there, in fact, is a school bus. So definitely a very good way to be able to automatically tag a large collection of images. I will say that this website itself, this whole interface, we built everything out using, we had two solution architects work on this. It took us about a week. The website's actually entirely serverless. So whenever we hit search, that's triggering a Lambda function. The website itself is being hosted in an S3 bucket. And then we're using DynamoDB to do all of our queries. All right, so the second demo I want to show, I'm actually very excited about. This is a project we're currently working on with our team, partnering with the ML Solutions Lab. And the ML Solutions Lab had this model that was already built. It's a single-shot detector model. And what we're trying to do is retrain that model for a very cool use case that we recently received. So not too long ago, there were a series of hurricanes that hit the Caribbean and had a pretty bad impact on the island nations down there. And it had the teams thinking, you know, whenever they're in a scenario where you have to go out and assess the damage from a disaster, a lot of times roads are inaccessible. It's very difficult to get around. So what they wanted to do was be able to send the disaster teams out with a drone and then be able to fly that drone around the area and have it do inference on the spot and kind of assess, all right, How many buildings are still standing? Are there trees on the road? What's the overall road conditions look like, and things like that. So what we're working on here is actually training a model that will be able to do detection on objects in real time from drone data as it flies through. And to make it even a little more difficult, we'll also be operating in an environment that has limited network connectivity. So I'll go ahead and play. It's kind of what we have thus far. So right now we've been training it primarily on vehicles because we have a lot of training data for that. And some cool things here is that this model actually was pre-existing. So we went ahead and we packaged it up into a container, and then we used SageMaker for retraining the model. So we're able to use that on-demand training with this pre-existing model. And then with the recent release of ML inference for Greengrass, our next step is going to be to then deploy this model to a device that has Greengrass installed so that disaster teams can take it out to the field with them, fly their drone, and then run inference in real time. So this is definitely, I'm very excited about this project. We're seeing very positive results so far. So the next step is, of course, as with most machine learning problems, to get more training data. But again, I think this is a good demonstration of how we're incorporating our infrastructure services like the P3 for our custom models, but still being able to leverage our platform type services like SageMaker for being able to do that training and deployment. And then we're integrating with services like Greengrass to actually do the inference at the edge capability. So that's all I have, and I will turn it back over to Ben. Thank you.
So from here, last few minutes, we really wanted to just wrap up a little bit with some core tenets when it comes to building these systems on AWS. The first one that we wanted to talk about is building loosely coupled systems. So not necessarily picking a storage type that will define your analytics, not picking an ingest method that's going to define your storage type that will indirectly define your analytics. So you could definitely keep performance. A lot of times we like to show how you could use S3 with Hadoop and still have very, very good performance versus using HDFS. But it's all about building a loosely coupled system, and that really drives that future proofing. It really lets you start ingesting imagery, video, all types of different data sets, and start running these analytics as you want to address different business problems within your organization. And we're all about picking the best tool for the best job. So architecting in a way that it's future-proofing. It's interesting because a year from now, there might be very different ways of analyzing your data than the way we're analyzing data today, which is very different than how we analyzed data 2 years ago. So how can you put together an architecture leveraging these services to be able to future-proof as you want to evolve your organization, your business, your different agencies? And elasticity, multiple clusters. A lot of our higher level services like SageMaker, which we're going to talk a little bit more in a session later this afternoon, it really keeps really good methodology to be able to spin up your clusters when you're training and you're building your analytics. And those services will automatically shut those things down when you're not using them. That way, it really keeps efficiency, keeps your costs low, and lets you do more experimentations and that sort of thing. And I think it was a pain point in my past life, so definitely don't forget metadata management. Being able to find your data. If you store a massive amount of data out in the cloud in AWS, and you don't know where it is, you can't find the different pieces of information that you're looking for, it's almost like you don't have it anymore. So look for very, very effective metadata management. At the storage side, picking the right storage for the right job. So S3 is really great for data lakes, but I wouldn't use it for a database. I wouldn't use it for a graph database. I wouldn't use it for a NoSQL database. So picking the right storage tiers and not necessarily one storage tier as well. So we have many, many customers that are having data funnel into S3. They're populating materialized views in databases, in data warehouses of that data to be able to drive transactional data, transactional systems, graph analytics, that sort of thing. And one of the things I like to say is big data analytics, machine learning doesn't have to be big costs. So it's all about making sure the services that you're leveraging are being done in an effective way, and our services really help enable that, and using the right tool for the right job. So that's what we want to cover in this session. Again, there's a lot more detail on the machine learning side on the last session in the tech track today. I think we're going to take some questions outside because I think they need to prep the room here. Thank you again, and please remember to fill out your surveys. We definitely look at every note that we get. And thanks again.